Hello. So welcome back. I hope you had a decent break. Hopefully you found some time to do some fun stuff. Over the break, I tried to build an outdoor planter. Still working on it. Put up this cool piece of art, and I put a little streak of teal in my hair. Just some things to keep me busy and safe at home. Hopefully you were likewise busy and safe at home. So we are definitely firmly in trimester 3 at this point, and this last trimester of stats is going to try to tie together everything we've done and sort of make sense of why it all matters. So the last couple of units are very much about the concept and not so much about the accuracy of the math, which for most of us, that's a great thing. One thing we do have to do first is get used to using an online calculator. Since most of you don't have graphing calculators at home, like the kind we were using in the classroom, I found a couple of options online and I picked what I think is the most straightforward option. So our very first lesson will be kind of an overview of the unit that we're starting and getting a chance to use this calculator and get used to it. If you do have a graphing calculator at home, I'll post another video later about how you can use it in place of this one. Because all the concepts are the same, it's just a different type of calculator. All right, guys, I look forward to hearing from you, and stay safe and stay home. So the beginning of this unit is called Is It Normal? Remember way back in September, we talked about what is stats, and we talked about the 3 Ps. So I said stats basically had 3 uses. Those were the 3 Ps. You could persuade with it, you could predict with it, or you could propose a policy change, which was a combination of both of those things. Basically saying if you were able to predict and you were able to persuade someone that your prediction was a good one, then you could propose how you could change a policy, basically how you could make something even better. So stats is all about data analysis. It's about making sense of the data so that you can make those choices. And once you've made those choices, that produces more data. And then, as you might expect, that means it sends you right back up here to do more data analysis. So it's a cycle. Well, one of the cool things we have figured out with statistics is that most of the data in the real world, and especially in the natural world, is normal. And normal data is pretty nifty because it allows for a couple of really important things. One of them being optimal prediction. It means it gives us a really good idea about how likely something is or isn't to happen. And that's why our last unit was on probability. So if we have normal data, we can do a lot of really cool stuff with it. That means, of course, that we need to know, is our data normal? So when we first heard this term even, we were looking at histograms. So we were looking at something kind of like this. So our very first time we saw histograms, we saw these 4 types. And I asked you to start by finding the mode. Now the mode would be the tallest bar because it has the highest count. You find the tallest bar, and then you drew an arrow to whichever direction had more bars. So my arrow goes like this on this one, because there's more bars to the right of it. That means this histogram had a right skew. And that word is spelled out for you right there. If I look at this histogram, I can see that this is my tallest bar, so that's my mode. There's more bars to the left of it, which means this is a left skew. Now my last 2 shapes, I only really care about one of them. If I look at this one, I should notice, here's my mode, but there are just as many bars and they're just the same height on the left and the right. That means it is normal. On our last shape over here, we notice we can't even draw the star because there is no mode. So this one was uniform. Now, uniform isn't a shape that happens very often, so we don't really care too much about it. We just need to know that it is one of the 4 shapes. So if a histogram has a right skew, that means that it actually looks like this guy down here. Now notice this one's called positively skewed. That's another name for right skewed. And the reason they say it's positively skewed is because it shows that the mean is greater than, in the positive direction, more than the median. And that's what this is saying right here. The mean is significantly greater than the median. A left skew is this guy over here, and it's also known as negatively skewed. And you can tell that's because the median is less than the mean is less than the median right here. And then you get to the normal no skew right here in the middle, and you should see that the mean, the median, and the mode are all right here. So filling in these notes right here, the mean is equal to the median and the mode. For uniform, the mean is usually equal to the median, but there is no mode. So after we looked at histograms, we eventually looked at some box plots like this. And one thing we should notice in these box plots, we still did the right skew and the left skew. So this one would be right skew, as would this. And these two over here would be left skews. This guy down here is what it would look like with a normal distribution. So if it's normal, there's just as much data on the left as the right, and the median right here, that's what this line represented, is also your mean. That is not true for any of this data. So any data that's skewed, sometimes it's easier to look at it as a box plot than as a histogram. So once you know if your data is normal, there's a lot you can do with it, but that means you need to figure out, is your data normal? So here's what I need you to do right now. Like seriously, totally, you gotta do it. I know you can figure out the mean and the median and the mode with a calculator, any basic calculator, but we're going to be using statistical functions that you are not going to want to figure out by hand. So I want you to go to this website. You can even pause the video and go to it. www.calculator.net/statistics-calculator.html. When you go to it, you should see a page that looks like this one right here. All right. So if you go to it and you don't see this page, check your spelling, check your typing. This is what it should look like. All right. So let's look at this page for just a second. Now remember when we were finding mean, median, and mode and stuff like that, we learned all of the symbols in our calculator. So remember this guy right here, the X with the line over it, we called it X bar, and that is your mean. That's what you're gonna use for these next couple of examples, okay? But you need it because you see these weird looking guys, we are going to be using them very shortly. All right, so if our data is normal, it means our mean equals our median equals our mode. In other words, they are all the same or very, very, very close to each other. So our task today is to figure out, is this data normal? So the first data I gave you are golf scores for a team. One person did 70, one person got 72, 74, 76, 80, and 114. And golf is very strange in how it scores. The lower you score, the better, because that means it took you fewer swings to get the ball in the hole. So this person who scored 114 is not very good at golf. So once you have gone to this calculator and you saw the screen I just showed you, this one, at the bottom right here, it tells you to provide values separated by a comma below. Yes, you need to put in the comma. So I put in these 6 values separated with the comma, and then I clicked on the green calculate button, and this is what I got. So it gives me a whole lot of information in here, which is great. It tells me the count. That tells me how many data points I put in. It should be 6, and it was. It tells me the sum if I added them all up. Then it tells me the mean or the average. That's 81. So I have a mean of 81. My median is 75. So it put them in order from least to greatest. And since it was an even number of numbers, it took the average of these two in the middle. It tells me my mode, all values appeared just once. That means there is no mode. And then if you look down here, it tells you some other stuff, some of this, which we're going to get into, like the standard deviation, the sample standard deviation, and what variance is. So based on this analysis, is this data normal? Our mean is 81. Our median is 75. We have no mode because all values appeared just once. So are they the same? No, they definitely aren't, which means this data is not normal. So we would go back up here, and to answer this question, I would write no, it's not normal. All right, I want you to do the same for numbers 2, 3, and 4. So go ahead and pause the video, try those 3, and then come back to check your answers. All right, hopefully you paused the video and now you're back to check your work. So on number 2 in the calculator online, you should have gotten these results. So the mean was 84, the median was 83.5, and there was no mode. So based on this, we could say it's most likely normal. It would really help if we had a mode, but we're gonna write yes for now. For number 3, here are the answers we got. 65.2 versus 65, still no mode. So again, yes, that's pretty darn normal. And on the last one, our mean and our median were both 3.25, again, no mode. So yes, most likely that is normal too. On your practice, I'll try to make sure they actually do have a mode so you can compare and see that all 3 really will match. But this is what you're going to be looking for in terms of whether or not it's normal. Do these 3 things equal each other, or are they very, very close? And the next lesson, we'll talk about what that very, very close, how we could actually measure that. All right, guys, check this out. See what you can make of it. Let me know if you're having any issues using this calculator.